Okay. Hi, everyone. Welcome to today's Carpenter Working Group meeting. Um, so we can go ahead and get started. In terms of project updates, we got two main ones. We at least from the Kubernetes 6 Carpenter repository, there have been two patch releases for the 1.5 and 1.6 minor versions. Um, these are yet, at least from the AWS provider side, we're still pending on doing a release to include these changes. But they are at least released from the upstreams, just as a notice. In terms of RFCs, does anybody have any RFCs we would like to discuss?
I had it when it's been there. I think it's just the registration TTL. I just want to. It's partially my fault. I should have replied. I did not see those responses to the uh, RC, but I wanted to see if we can get a quick look. If we want to change the name, that's okay. I just need to know if that's the direction we want to go. And I can update that. I think Jonathan was mentioning TTL is not something.
Yeah, I think, yeah. Jonathan, do you want to talk more about that?
Sorry, can you repeat? I just was distracted by something else real
Oh, no
quick.
worries. This is around the registration TTL. You mentioned something like, "Oh, we don't really use TTL," which I think that's true. Yeah. So I'm happy to change the name. Does something like registration deadline work, or like, I can throw some other ones into that thread. Is there something you're looking for specifically around the name of the variable?
I didn't have any thoughts off the top. What you could do is you could just throw them all the options in a comment and then just like ask for a vote, basically. And then I, so part of this is I've been off for 3 weeks, so I haven't had a chance to like look at this again.
No worries.
Yeah, I mean, I think in general, what I've seen in other PRs and RFCs is that you just like throw options in a comment and then people can just vote on them.
Sure, I can do that.
Okay.
Okay.
Anything else you would like to discuss about this? I think if I remember correctly, reading a few of the comments, a lot of the comments was centered around the fact that I guess we wanted more information at exactly what the delays that we're seeing here are. I know that a few of the use cases, I mean, that we call out here is like
Yep.
particularly, I guess GPUs and Windows, uh, bootstrapping. I don't know. At least from the comments, I was getting a sense that we wanted a little bit more like information around these. If it's like if there's some sort of a combination of instance types that can cause this, any particular workflows in the Bootstrap that can cause this. Can you elaborate a little bit more on that, Garvin?
Yeah, for sure. I think what we ran into is mainly like the installation of drivers for GPU.
Mhm.
The reason I listed the Windows is because I think someone else, I think Bryce previously had that issue, but I think they resolved that issue. I also believe last working group there was another issue that brought up changing the registration TTL from 15 to 30 minutes. I can try to find it, and I'll link that over too, because that was also an impetus to push this forward. I just don't remember where it was. But yeah, at least for us, it was mainly the driver installation for NVIDIA GPUs. For us, it takes a little bit of time. In addition to our bootstrapping tends to be a little long. That's
Mhm.
why we do have a need for greater than the existing default. Um, yeah.
Okay. Yeah. Okay. Yeah. I think having that additional context here would definitely help.
Okay.
Okay. Cool. Anything else? Anybody else have any questions around this RFC or any comments? Cool. If not, we can continue on. Um, okay, so we did that. Any other RFCs anybody would like to discuss? Cool. If not, we can move on to community questions. This first one centered around DRA.
Yeah, thanks, Garvin. Just a quick update to folks. We just a reminder that we're meeting most weeks, usually at this time, actually, off cycle from these meetings. And then today we met at 9 a.m. Pacific, so we didn't collide with this meeting. And we've got the first sort of housekeeping PR that's about to land, which will do what is stated there in the title. And Jason is making progress, kind of wrapping his mind around the explicit integrations that are going to need to take place from the changes to the cube scheduler allocator, given that Karpenter has its own abstraction for that and isn't able to simply reuse that code. So that's a bit of work, and that will go into the RFC, which I think we'll have a publicly shareable version of probably in the next week or two. And then just a reaffirmation that the scope that we're after for let's say the next 3-4 months is the sort of basic foundations of DRA. If you're familiar with DRA, you might be familiar with the term structured parameters. If you're not, don't worry about it for now. It's just is a few core APIs and new Kubernetes resource types that carry out the behavior of DRA. So we're scoping things to that. And the reason why it's even worth clarifying that is because DRA is a very it's a manifold set of stuff. It's not just a single thing. So DRA is now GA with 134, which landed yesterday. But what that means is that the core set of APIs and behaviors are GA. There's going to be a long tail of more or less continually arriving additions and enhancements to DRA for the indefinite future as the API expands. But we're scoping Karpenter to the similar scope for cluster autoscaler, which is that what we call structured parameters. I've been talking a lot. Any questions from the folks present? I know it's probably a lot if you don't know about DRA. Cool, that's it.
Okay, sounds good. I'm assuming this is just like the prep work, I guess, before I mean, to make sure that going forward, that Carpenter is able to disable everything, right? At least this particular PR.
Well, that I think it's totally fair to call that prep work. When that gets included, when that lands and it gets included in a release, what it will do is it protect protect the sort of Carpenter scenario from building new infrastructure in response to pending pods that Carpenter doesn't understand.
Mhm.
So it's a sort of defensive change now that is trying to get ahead of the potential where a Carpenter customer is using DRA in their Kubernetes cluster. And DRA, that represents new information in the pod spec, which Carpenter isn't able to interpret until we actually land support. And the way that it was introduced into the pod spec, Carpenter, not knowing about it, can simply interpret the other surrounding metadata in that pod spec and form an incorrect idea of the required infrastructure to fulfill the scheduling constraints. And so we just want to prevent that outcome where you're using DRA, you're using Karpenter, you expect it to work, but actually it's just thrashing, creating new infrastructure, reaping it, creating new infrastructure, reaping it. So this will ensure that that doesn't happen.
Good. Cool. Thank you. If no other questions, then we can move on to the next topic, which looks like it's capacity buffer integration.
Yeah, I was going to raise visibility for this. I didn't actually check if this was brought up in previous working groups. Have we discussed this? I assume not. I'm just looking.
Think was briefly chatted about, but I don't think we talked too much about it in one of the meetings. It's been a while though.
Yeah, I see. Like if I look at the notes, it's like 521 or something. It's like a long time ago.
Yeah, sounds about right.
Yeah. Anyways, this got merged, I think, a couple weeks back. It was while I was on PTO. But Quest Autoscaler is basically going to implement this capacity buffer API, which is kind of like there was a pod headroom API that came a while ago. I think we need to probably start thinking about, how do we implement this in Karpenter? Because it's going to basically be a shared API between the two projects and try and be like a common API in the autoscaling API group. So yeah, it's kind of like a heads up if anyone's interested. Reach out to me, reach out in the Carpenter dev Slack. Because I think we'll probably start thinking about building this like later this year. The idea is basically that, yeah, pod overhead. The idea is basically like you can pre-reserve capacity for pods that will come later, or create like an overhead so that it's easier for you to scale up, or you like expect higher degrees of like traffic, for instance, in your application, and you're just trying to make sure that like when you actually do need to scale up, you have the capacity available. Right now, this is a persistent overhead, so you create these capacity buffers that are under the hood. I think if you scroll down a manual, there should be a description of how this exactly looks, but it's basically under the hood, it's a pod template representation. So you can either actually, man, I need to refresh my memory on this, but you can either reference an existing resource that implements the scale sub-resource, and then it will basically just use that resource as a representation of what it should kind of create for overhead. Or you can create your own pod template, which like you have to create a pod template object in Kubernetes, and then you can reference that pod template if you don't, like if the shape of the pod is not already on your cluster. In either case, like the autoscaler would basically model that and launch capacity for pods that don't yet exist. So you always have that overhead there. It currently, yeah, it's persistent, so it doesn't like fill up. We have this other proposal for static capacity, which is more of like a, you under the hood, you set a certain baseline capacity and then it fills up. This is like just always keep it around. I think there's some thinking around like, would we eventually create an API that would allow us to like fill up that capacity for applications as well, but that's not in there yet. I think there's also some interesting things with worm pools I've talked with a couple of people about, especially with the introduction of static capacity pretty soon. I think that there's some interesting things we can start thinking about around like how we would configure like worm pool support. You can imagine that if you have like capacity that exists that doesn't have any running applications on it, that you could effectively worm pool those nodes automatically for users. And so I'm kind of interested in thinking about like whether, you could create a configuration option on a node pool or on this headroom that says like warm pool, or like there's like a warm pool policy or like some kind of like reservation policy that says either make this warm pool or make this active, and you either get active capacity or you get like capacity that's in a stop state hibernated, and it'll start up once you actually have applications scheduled to it. Like Carpenter will automatically start it, for instance. That was a lot. So I don't know if anyone
I,
has any thoughts.
I think this is cool to see. It feels like a huge thing. It's like almost as big as the RA. Like,
I don't know that I go that far, because I think capacity buffer, like under the hood, it's just modeling a pod. So it should plug and play like fairly easily with the existing scheduling algorithm. I think we have to kind of like see where the edge cases are there. But in general, I would think like, oh, you can just add this, like add X number of replicas as a count to the schedule resolve method when you're actually doing this pending pod scheduling, and you would just, the output of that would be new node claims that you could then use for um, the headroom.
I guess specifically around like if you want to add more to like the warm pool and stuff like that,
Yeah.
then it becomes much more complicated. Yeah.
Yeah, I think the wormhole support's just like an interesting idea, given that we're now having these like not just in time capacity kinds of things. So we have things that aren't running applications potentially at a given point in time. And if there's customers that want to save money, or like it's kind of, it's the trade-off between time and money. So like if you want to save money, you can configure this in this way, and then you save a little bit of money potentially. I think the baseline implementation, to your point, is like fairly straight. Hopefully, it's fairly straightforward. My assumption is that it would be, um, but I think we just need to like tease it out with like a POC or something.
There's a pretty cool option for just saying, like, if you enable something, depending on if it's static capacity or if it's capacity buffer, like agnostic of those options, just if you have a node that is empty, warm pool it. Like, you wouldn't have that in a dynamic node pools, obviously, but it might be just a nice thing for the AWS provider to support in general. Like, agnostic of how you get the headroom will warm pool your nodes that are Carpenter managed if they don't have any pods on them.
Assuming you have, are you assuming that you have like desired capacity that you need? So like for like static capacity and capacity buffer as examples, like if you, are you talking about in the generic case where you have empty nodes or just in those cases?
In the generic case where you have empty nodes that aren't, like if you can't consolidate them, because that was what you would do for dynamic, right? If it's empty, you get rid of it, right? But if it's Carpenter managed and it isn't getting deleted for whatever reason, and it doesn't have any pods on it, just like warm pool it. You could do it agnostic of those two like specific checks,
I guess
you know.
it's hard for me to reason about. Maybe there's cases there. It's just hard for me to reason about cases where you wouldn't just want to terminate it.
Well, it'd be for static capacity or
Oh
capacity buffers.
So yeah,
Yeah.
that was my question. Is like in those scenarios, that's when it makes sense. Outside of those scenarios, I think it isn't. You're not talking about generically with any empty node. You're just talking about when there's simulated capacity but no real capacity, like applications on those nodes.
Yeah.
Okay. Yeah.
I guess it's a semantic difference, I guess.
Yeah.
But yeah. Jack.
I think the operational scenarios in which that would happen, I mean, that sounds super convenient to, oh, I need a buffer. Oh, I've already got a buffer. Cool. I'm already good to go. In practice, that's going to be a super rare occasion because your buffer actor is going to be winning the race every single time in terms of other like consolidation efforts. So by the time you notice that you have extra or an empty node, your buffer actor has probably already carried out additional infrastructure provisioning. And so it seems to me like it would be very rare that you would suddenly have the availability of a bunch of unexpected capacity, like let's say workloads got scaled down for traffic reasons or whatever, which corresponds with the amount of buffer that you want in your cluster. I'm not trying to be a downer, but I think one of the things that I've been bringing into the buffers API conversation is how do we deal with all these races, you know? Because you really do need a separate controller to continually carry out some static configuration of I always want this much headroom, even if it's like relative to workloads. And how do you deal with that racing with all the other things that we already have in play with mature solutions like Carpenter and Cluster Autoscaler?
Yeah. There's also this. Let's see if I can find it. There's the discussion that's happening in the community around like workload scheduling, which also has scheduling reservations as like a topic of discussion in it. Trying to see if I can find it. Oh yeah, here it is. Okay. Post it and I'll also add it to the work log. But there's kind of some interesting conversations about like how do I like kind of well, and I guess there's also this doesn't have the use cases in, oh no, maybe they moved them into separate tabs. Yeah, so there's a use cases tab in this document, but basically it's there's some discussion around like how do you have a kube scheduler that can basically do reservations so that it can only allocate the capacity to certain workloads. So in the case of like capacity buffer, you would basically say like, okay, I'm going to create a node, but it's going to be specifically for this workload, which works well in cases where well, I guess because it doesn't fill up, it doesn't quite work in a way that would help like something like Q, where you could like pre-reserve the capacity. But you could imagine like if you could fill up the buffer, you could use something like Q, pre-reserve the capacity, and then the kube scheduler will ensure that like only pods of a certain that have like a certain label on them will schedule that capacity. Without it being like strict workload isolation. Because obviously if you create separate nodes, that's a good way to ensure it. But That's all I had. So
Is there a release timeline for this? I guess how is that going to work? Do you happen to know?
you're talking about the workload aware scheduling?
I guess both.
Oh, well, capacity buffer, no, because I'm like, what are we just polling if people are interested? I know that we have
I
the
mean, I guess I don't mean in the Carpenter. I mean like generally within Kubernetes. I'm assuming since it's just going to be a generic API that both Cluster Autoscaler and Carpenter will be able to use. Is there just going to be like, is that going to just follow like the release cycle of like upstream Kubernetes?
Good question. So I think the plan right now, as I understand it, is that it's going to just be a custom resource group or a custom resource like API version, and it's not going to be like a native Kubernetes API to
Hmm.
start out. And so you would install that single custom resource definition in your cluster, regardless of whether you're running cluster autoscaler or Carpenter. But the goal is that it's agnostic to the autoscaler that you're using. Like it applies to both.
Gotcha. Okay.
Plus one to that, yeah. I would expect it to be a sort of separate thing that then gets the actual controller part will be specific to the autoscaler, but the CRD will probably be sort of settled on and published as a separate thing. So there was something that happened like a year plus ago called provisioning request, which is in the autoscaler repo, which is similar like a CRD, and I believe GKE is using it. So the actual implementation is maybe opaque, but the API itself is sort of separate from any particular project. It's just a CRD that's published from a queue builder spec in the autoscaler repo.
Gotcha. Okay. Thank you. Cool. If nothing else on that, does anybody else have anything they would like to discuss or any other questions? Okay. If not, then I think we can call this meeting to an end.
I guess I have a quick thing I want to chat about. No one else thinks. I'm wondering, so I've been trying to figure out how to diagnose issues within Carpenter. Well, not within Carpenter, but within our node pools where, say, oh, we forgot to make our daemon sets no select to in the node pool, and we just forgot about it, and now the Carpenter doesn't know about that daemon set. It's going to hit that node pool, and we didn't subtract the right amount of resources from the nodes it launches. Um, some of this logic, I don't know if it makes sense within Carpenter as like a diagnostic thing. So I'm wondering if it makes sense. I've been writing something that's like, I guess agnostic to like the CNI metric helper, but like, I guess Carpenter helper that is going to live side by side with Carpenter, but in MIT's metric, they're more specific to diagnostics and understanding why some common questions that people seem to have around like, oh, my nodes are not being consolidated, or Carpenter's not launching new nodes, but my pod's not landing on there. Pieces like that, and try to capture that logic in a separate thing. I guess my question is, does that make sense as something that doesn't live in Carpenter but lives somewhere else? I don't know if people have thoughts around that. As I'm trying to like build something like this out for myself, but then also I can also like, I guess, open source it even if people find that valuable, but it didn't feel right fully to be in Carpenter, but I'm not 100% sure.
Yeah, I think we've generally had discussions around having some sort of a debugging tool that allows us to give us more additional observabilities, like users to give them much more observability. I'm not exactly sure if that's what you're like thinking, but I will also say for like the node overlay design, one of the key components that we would like to eventually expand on is that kind of observability piece where it doesn't necessarily make sense for a large sum of data or like these very niche scheduling decisions to or like not niche but rather like scheduling decisions that have a lot of inputs to go into, to be either logged or, us emit
Right.
events or any, metrics of that nature. It may be really like we've had kind of similar discussions with it. Nobody has taken, at least as far as I'm aware, any kind of initiative to begin that. So I think at least for me, I plus one that seems like a really, it would be a really good initiative generally for the community.
Okay. Yeah, this part of it at this time is still rough, but then I can share when I'm more done with it or have made more progress with it. But the hope was like essentially I'll expose Karpenter internal like scheduling logic and apply some like, oh, these are common cases that I ran into that I think I want to know ahead of time. And emit, I don't know, metric logs. So I was like, oh, this is happening. And I don't think it makes sense for Karpenter to know explicitly, but then we can offload a lot of that status or stuff like that out of Karpenter when it doesn't fully make sense. But yeah, once I have something a little bit more concrete, I can share it in the dev channel or something.
Yeah, that sounds good. Cool. Anything else anyone would like to discuss? Okay. If not, then we can give everyone back 30 minutes. Thanks everyone for joining.
Thanks.